Hello everyone, welcome to our videos on C programming. So in this video, we are going to be focusing on the topic of modifiers. So there are certain keywords in our C language which can be termed as modifiers. So this topic actually comes under the concept of our data types. So we have already discussed about what is a data type and what are the classification of a data type we have in our C language and mostly about our primitive data types. We have already discussed on this. Now, we have certain keywords. Say, for example, these are the keywords what I have. That is my short, long, signed, and unsigned. So these are the keywords which is present, which can be defined as my modifiers. So what is the usage of these modifiers? Or what is the usage of these keywords? So these keywords are used to change the behavior of my primitive data types. So we already discussed, as I said, about the primitive data types. You remember int, float, double, char, and void. So 5 primitive data types we studied. So in that, I told you void is something we are going to make use of only in our advanced concept like functions and pointers. So we shall not be discussing about that particular data type right now. Okay, so what is the focus of it? The 4 data types, which is int, char, float, and double. So these modifiers are used to change the behaviors of these primitive data types. So modifiers, modify, the name itself suggests something. So let us see what is the use of it. Right, first we are going to be taking the 2 keywords signed and unsigned. So I have 2 keywords which is signed and unsigned. So first point what I have to remember is that these keywords can be used only on integer data type. That is, I can make use of it only with integer category, that is whole numbers. That means what? I cannot make use of it on float or on double. So this keyword is not applicable on a float or a double data type. It can be applied only on the integer categories. Okay, now what is the use of these keywords? First thing is, you know that integers are used to store whole numbers. So numbers, when I talk about numbers, numbers can be a positive number can be a negative number also. So these 2 keywords are used to give that restriction. So restriction on the value that is going to be stored inside the variable. So when I want a variable to store both positive and negative numbers. So you want to create a variable in such a way that it can accept both positive number also and the negative number also. Then what is the keyword we are going to be using? Signed. So we are going to be making use of the keyword signed. So signed means what? It allows both positive and negative numbers to be stored within. Now, I want to give a restriction. I want only positive numbers. I don't want my variable to store any negative values. So then what I have to use? I have to use a keyword called as unsigned. So that is the usage of these 2 modifiers. So to provide that a restriction, say for example, I want to create a variable called as age. So we know very well, age can never be a negative value. Think in a real-time scenario, guys. Age can never be a negative value. So if I create a variable like this, int age, okay, then this by default, what do you mean by this? This by default is creating a variable like this, signed in age. So this keyword signed, I just told you, signed means what? Signed allows the variable to store both positive and the negative values. So remember, this is the default value. This is the default modifier. So it is not compulsory for us to declare this. It is not compulsory for us to use this keyword sign. Why? Because it is the default. Default means what? Even if you are not giving it, my compiler will automatically take it as a signed only. So both of these statements are correct. If I give here like this, signed in date, this is also correct. This is also correct. That means what? This age can hold both positive number also, can hold both negative number also. Say for example, I'm saying age is equal to 10. Valid. I'm saying age is equal to minus 52. This is also valid. So both are valid in this scenario. Remember, find default modifier for a variable. Right. Now, even if you don't give this also, the compiler will automatically add that keyword with our variables. Right. Then if now, as I told you, age can never be a negative value. So what I'm going to do, whenever I'm going to create a variable like this, which I feel it should not hold any negative values, then what is that I'm going to do? I am going to declare this as unsigned. Now this is mandatory. This is mandatory. If you want to create a variable that should not hold any negative values, then compulsory you have to declare it with this keyword unsigned. So unsigned int age. So now this variable can hold only positive numbers. That is what these two keywords are going to be doing for me. And this comes under the topic of our modifiers. Right. Now, looking at the other keywords, I have another two keywords, which is nothing but short and long. So now let us try to understand what are these two keywords going to be doing for us. So what is the usage of short and what is the usage of this long keywords? So again, short. First, let us start with short. Short keyword can be applied again only for integers. You cannot use it for any other data type, not for float, not for double. No. Okay, so again, short is a keyword that can be applied only on integers. And now, what is the usage of it? What is the use of this short? Now, imagine, I already told you that my compiler is a 64-bit machine. Okay, my system, my laptop is a 64-bit machine. Okay, so in a 64-bit machine, int occupies how many bytes of data, you remember? 4 bytes. So integer is going to occupy 4 bytes of memory. So I am going to create a variable like this, int age. Now, what is the value of age? Think in a real world scenario, what is the maximum value age can have? Age of a person, okay, age of a human being. How long can he be alive? He or she can be alive. Age can be minimum 0. That is, the person is not born at all. Okay, maximum age 100, 150, 200. So let us assume 500 years. He is living for 500 years. That too, only that much, right? So why I should waste 4 bytes of memory on to hold such a small value? I'm just going to hold from 0 to 500. 0 is the minimum value. 500 is the maximum value. So for storing such a small data, why should I waste 4 bytes of memory? So what is that I'm going to do? I am going to make use of this keyword called as short. So modifier, modify, change. So I am going to change the behavior of this int. So what I'm going to say? Short int age. So short int age. Now what happens? What is the use of the short? First, please remember it is used to decrease the memory. It is used to decrease the allocated memory. So please remember, whenever you are creating an integer with this short keyword or with this short modifier, then only 2 bytes of memory will get allocated. So how much of memory space is going to get allocated? Only 2 bytes. So thus you are going to save 2 bytes. So instead of 4 bytes, here I'm going to allocate only 2 bytes because as I said, my data is very small. So I don't require 4 bytes. So how to do that? Short. Same way. Think. I told you that in a 32-bit system, int occupies how many bytes? 2 bytes. In a 32-bit system, integer occupies 2 bytes. Now, I want to store my mobile number. So, any mobile number you take consists of 10 digits. It consists of 10 digits. So, it is not possible for me If it is a 32-bit system, only 2 bytes of memory will get allocated for it. So within 2 bytes, it is not possible for me to hold a 10-digit number. The capacity is not there. So what can I do? How to enhance? How to increase the capacity? So short is used to decrease the capacity. Now I want to increase. So how to increase? I will be going for this next keyword, which is long. So what I'm supposed to do? Long int mobile number. So whenever you declare this variable as long, okay, long int, it occupies double the size. So what is the usage of the long? Now long int is going to occupy 4 bytes. So if you are going to declare it as a long int in a 32-bit system, it will occupy 4 bytes. Same long if you are going to give in a 64-bit system. If in a 64-bit system, you are going to declare the variable as long int, it will occupy 8 bytes of data. It will occupy 8 bytes of data. So that is where the thing is, modifier. So remember short. Short is used to decrease the memory capacity. Long is used to increase the memory capacity. So according to our requirement, we can make use of the memory efficiently by making use of these two modifiers. According to our program's requirement, we can adjust the allocated memory size to our requirement. Again, one more important point is this long modifier can also be used with a double data type, not with float. Remember, you can't use it with float, but you can make use of it with the double data type. So I can declare a variable like this. Long double, any name, whatever you feel like. So I'm saying long double x. So please remember, double already occupy 8 bytes. Remember, when you declare a variable as double, it occupies 8 bytes of data. So when it is a long double, what happens? It takes 16 bytes. It takes 16 bytes, a very large number. It has the capacity to hold a very, very large number. That is the advantage of my modifiers. So signed and unsigned, it restricts. Signed and unsigned modifier, it restricts what type of data I can hold inside the variable. That is what type of number. Whether it is a positive number or is it a negative number. And this other two modifiers, which is short and long, it is used to increase or decrease the memory allocated respectively. Right, so these are the modifiers and this is the usage of it in our program. Right, thank you.